You need permission to share your screen. Yeah, it's yours.
Okay. So Vivian, you can start.
So hello, we're group Antonia and Vivian. We're happy to present our analysis of Barcelona's rental price prediction. Before we begin, I'd like to guide you through what we are going to present today. First, we're going to present, we'd like to define our goals and the framework of the project. Second, we'd like to explain you the data we used. And third, we would like to show you the models we tested. And finally, we'll deliver our final conclusion. You might wonder why we were intrigued by this topic. Surprisingly, rental price in Barcelona has been continuously increasing since 2013. Between Q1 2014 and Q4 2019, the rental price went up from €647 to €937, which is around 45% increase. On the other hand, the salary increased only by 0.08%. We researched and found some articles related to this topic, and this article mentioned that the possible cause of the continuous increase of the rental price can be multiple reasons, such as increase of rental houses from tourism, investment of speculative capital, high price of real estate market, and gentrification. So we wrote our hypothesis as that at a short-term rental platforms such as Airbnb detracts the home from long-term real estate market, and there is a noticeable impact of Airbnb on Barcelona's rental price. So in order to test our hypothesis, we wanted to predict the rent price per neighborhood in Barcelona and to find if there's any impact of Airbnb on Barcelona's renting price. So apart from modeling, in order to carry out the valid outcome, it is also equally important to have a clean and a good data source, as it will be the source for your final model. So first, we use Airbnb data. We downloaded the Airbnb data from project inside Airbnb. They already collected all Airbnb data from all cities that the Airbnb is operating. And the project includes data such as the flat, and if the flat is available for 365 days, how big the housing is, and if the host is super or mega host. Next, we use Barcelona's open data. This is an official website from Barcelona City. This website has city-related data sources such as demographics, economics, and city facilities. We found population data and unemployment rate per neighborhood and education level per neighborhood. There are more data available in the website, but not all the uploaded sources had the yearly range values that we wanted to get, as we were focusing on the time range between 2015 and 2020. So in the end, we had data from 5 different sources and we merged them all together. Since all the sources of the data are different, our data did not have one unified structure, and we had to clean and merge. For the Airbnb data, we aggregated count of housing, mean price per neighborhood, etc. And the reason why we merged is to compare values from neighborhood to neighborhood. For the data set that are downloaded from open data at SCN, we simplified education levels into 3 classes, bachelor holders, medium, and education and no education, from 5 different classes. So the rest data was also all simplified and merged. Then we cleaned the NAN values, as some models are very sensitive to NAN values and can change models rather if the value is not given. So we wanted to make sure our model have all necessary values for the outcome. Could you go back to the... So we did not have Airbnb data for these quarters. And the next slide. And the next slide shows that some neighborhood didn't have enough price values. To handle this situation, we use KNN inputters from scikit-learn. K nearest neighborhood classifier is one of the introductory supervised classifiers. KNN works on a principle assuming every data point falling in near to each other, falling into the same classes. In other words, it classifies a new data point based on similarity. So now the data is ready. Antonia will take over explaining the finding of our data.
Yeah, I'm going to show you some graphs and plots that we did with all the data that we gathered. I want to start with the price, the rental price that it's our target. And I want to show you how the rental price grew from 2015 until just before the pandemic. And it grew in every neighborhood, except for those in the district of Les Corts, that is more or less stationary. This neighborhood is the neighborhood with the highest price rent in Barcelona. It's Pedralbes, it's a neighborhood where wealthy people lives. And this one is this district is Ciutat Vella, is one of the most tourist neighborhoods in Barcelona. Also, Eixample is other neighborhood with a lot of tourists, with a lot of tourism. We see that the prices grew, but how are they distributed, these prices? Because we see that there are very different prices per neighborhood. So we did a map to see it. And if we see the price, this is Pedralbes, this is the neighborhood with the highest price in Barcelona, and this is Eixample. It's one of the neighborhoods with more tourists in Barcelona. And we see, as the years pass, that the price grow, and the prices grow, and they feel like a belt in the middle of Barcelona, and the outside of Barcelona is more cheap. The neighborhood, the district where the prices grew more is this neighborhood is San Martí. And in this neighborhood, the prices rise a 60%, and in the center, the prices rises between 40–50%. And now I want to show you how Airbnb has changed on time too. Let's see first the number of Airbnbs in Barcelona. In 2015, the Airbnbs were concentrated in the center neighborhoods. These all are very touristy neighborhoods. And we see that with time, the number of listings grew and grew until just before the pandemic, and then went down a little. We don't know how it's going right now. But you see that the impact is most in the center. I want to show you another plot. This one is for all Barcelona. This is the number of houses for all Barcelona. We started at 2015 with 12,000 listings in Barcelona, and just before the pandemic, Barcelona had more than 20,000 listings. So the houses increased in a 71%. We see a gap when the city council here tried to reduce the number of Airbnb housings, and they forced the Airbnb to remove like 2015 ads. Let's see something more about the Airbnb, because it's very interesting how the number of mega hosts were increasing. The number of a mega host, we consider it a mega host, a host that has more than 100 housings posted in Airbnb. And this, we see how they group in the center. So from approximately 2018, when Barcelona forced to remove the ads, the number of megahosts grew. About the distribution of the people and the education, I want to show you something very interesting. Because if we check the ratio of bachelor degrees in Barcelona, we see this belt again, the belt that we saw when we were checking the rental prices. So the people with more wealthy are people who can pay rents in this belt, are people with more education. And we already had information about the unemployment. And this is super interesting because the unemployment goes exactly the reverse. It went down, but then when the COVID pandemic hit, it went up again.
Miss Antonia.
Yep.
Hi, what meeting is this?
Excuse me?
What meeting is this?
Oh, this is a project presentation for a final course. Yeah, a final presentation for a course.
What are you?
Okay.
What are you looking for?
Oh, I was just making sure I was in the right meeting.
Okay.
Is it all right if I don't show my face? I'll put a picture up.
Yeah, it's okay. So this is our most important variables, but I want to show something. If you're not Spanish, if you ever want to go to live to Barcelona, the neighborhood that you have to choose is, this one. Here is where most of the foreigners live in Barcelona, near the Barceloneta and the sea and everything. So that was about our data.
So again, I'd like to share.
I'm sorry about that.
Sorry again. Oh, sorry, I'm just going to continue. So I'd like to show you what models we used. We chose 3 different models. First, ARIMA, an XGBoost with time features, and Profit and Your Profit. ARIMA learns from the past data and predicts the future based on your previous values. It is highly important for the model to be stationary. We chose ARIMA model as it deals well with the short time frame. And the time range of 5 is not too short, but as we are dealing with a quarterly data set, in the end, we had only 24 time periods. So we decided to go for ARIMA model. However, the ARIMA model sometimes work better with multiple features. And in our ARIMA model, it only includes the pricing value, so it has the limitation. I will share the result later. Next model is XGBoost. Since XGBoost is not a time series model, to convert XGBoost into a time series model, we had to add time-related variables to the data set. Those can be legs of the rent prices and the rolling mean and the holiday periods. But just like other models, XGBoost has a limitation as well. As tree-based models are unable to predict values that fall outside of a range of values of the trained data. This is because it's decision tree space and it's operating recursive splitting cannot really go out of this range. To solve this problem, we could remove the trends to make the time series stationary and forecast the trends separately with a linear regressor, and we add the trends to the XGBoost result. Next model is Profit and Your Profit. It's an additive model. Profit automatically detects change in trends seasonality by selecting change points from the data set. Profit is optimized for the business forecast task as it can deal with strong multiple human scale seasonalities, like days of week and times of year and important holidays that occur irregular basis, such as like Super Bowl, and a reasonable number of missing observation or large outliers can be well dealt. And a neural profit is an additional model with neural network. Of course, it has its limitation. Profit is not as accurate as ARIMA model, and a neural profit works better with a bigger data set. Those are the models we use, and I will explain ARIMA part, and the rest Antonia will walk you through the presentation. And before we begin, we'd like to explain you that we chose certain neighborhoods to analyze. So the reason why we chose those neighborhoods are that we were curious about Airbnb's impact. Oh, not done yet, sorry. Airbnb's impact on rental price, and those certain areas tend to have more tourists and more Airbnbs, as you saw the interactive geomaps. And on the other hand, Pedralbes is located slightly far off from the center, but it still has the highest rent price. So it's not known to be a tourist area, but still has the highest rent. We're also curious about what drives the Pedralbes renting price so high and compare the rent price patterns over the 5 years to the center one's patterns. I picked L Varigotic to compare to the Pedralbes. It represents all center area as I did not add any regressors. The additional features were not really taken into. So I checked the trends of the center located neighborhoods, and all trends the same goes up and they behave similarly. As you can see in the graph left-hand side, you can see that the data is not stationary. But being stationary is important for ARIMA models, so we decided to go through the log transformation. The graph right-hand side is the method log transformed as subtracting mean, but it still does not have stationary data. Next, we tried exponential decay. It behaves better than the subtracting mean, but it still is not stationary. So we finally went through a time shifting method using shift function for the pricing values and drove the NA values. And it still does not seem perfectly stationary, but by add floor test, it turned out to be stationary. So we picked the log time shifting method and fit into our original values. The graph left-hand side demonstrates the original price in blue and the prediction in red. And we fit it into the model, and graph right-hand side is showing the prediction of next 4 quarters. It seems like the price of the center area will go down in the next following 2 quarters thing. And let's compare the neighborhoods with the highest rent price. Pedralbes time series was already stationary, just to make sure that we went through the add floor test and it confirmed the stationary of the data. However, since our other graphs were in log transform scale, so we transformed the time series, the Pedralbes time series into the log scale 2 to compare the model to L-Varigotic's one. Then we did stepwise regression to check what the best orders for the models will be, and the best model turned out to be 0, 0, 0, 1, 0. And again, we fit into our original values to the graph, and then the graph left-hand side to demonstrate the original price in blue and prediction in red. And we fit it into the model, and the graph right side is showing the prediction of next 4. Like price of Pedralbes will go up and down. So there is a clear difference in rental price behaviors. Center located ones will go down in the following 2 quarters. On the other hand, the neighborhood with the highest rent price will go up in the following 2 quarters. So for the modal conclusion, it was really important for Arima to make the data stationary and to make the data stationary before fitting into the model. Log time shifting worked the best. The model's result will change if we add regressors, but since we did not additionally add any regressors here, we can't say it's the best model. However, it still carries the values by showing the clear difference in pricing patterns and between the center locate area and the one with the highest rental price. And from XGBoost, Antonia will walk you through.
So for the XGBoost model, as Vivian told you, XGBoost is not a time series model. So we had a lot of features about unemployment, about the education, but we didn't have information about the evolution in time of our target, that is the rental price. So what we did was to add this information to the dataset. And what we did, we separated the data sets in neighborhoods, and we added the lags of the rental price, the 4 past quarters, and we added the rolling mean. We used these new features one at a time with the XGBoost model to see which one worked better for the model. We checked which one improved the best model using the root mean square error. After creating the features, this is how the dataset looks. You have here the time series of the prices. The lag one is just the shifted prices. So this data has information of the previous prices. And this is the rolling mean, and this there will be another features in the dataset. So we started with Pedralbes. This is as we told you, this is the neighborhood with the most high rental prices, where the wealthy people of Barcelona lives. And we found that the best fit results, but adding the rolling mean as a feature. So this prediction takes the tendency of the series, even it's not that detailed. And what's interesting about the XGBoost is that XGBoost, after it's fitted, it delivers which features were most important in the fitting, in the regression. So we plotted them, and we saw that for Pedralbes, the features more important for the prediction were the long-term unemployment, the ratio of professional Airbnb hosts. This is people that have more than 15 housings in Airbnb, and the number of households that have one Spanish living in it. There is also Airbnb ratio business. This is the ratio of hotel rooms versus another type of housings, and with window mean and other features. We did the same for the barri Gothic. This is the barri in the center of Barcelona, in the old town. And the best fit we ended with the rolling mean as a feature. We checked also the features, the most important features. And in this case, in the barri Gothic, that is in the center of the city, it is very tourist, all the most important features are related to Airbnb. This one, availability 365, is a feature that indicates if how many days in a year a housing is available to be rented in Airbnb. This is the mega host ratio that we talked about. Is the ratio of hosts in Airbnb that have more than 100 housings. Professional ratio, the hosts that have more than 15, and then the window mean, that is the feature that we added. But In Varigotic, Airbnb, it's very important for the prediction. La Dreta de l'Eixample, it's another neighborhood, very tourist neighborhood. It's near La Sagrada Familia, and in this case, the lags worked better. Checking again the results of the importance of the features, we again see Airbnb related features. And again, it shows the unemployment, like in Pedralbes. With this model, the best accuracy we got for the first 2 quarters, like we saw in this graph. In the center neighborhoods, Airbnb features are very important to predict the rental price. And one thing that we saw is the rolling mean as a feature works better for nearly stationary data. And the lags works better with data that is growing or falling. And this makes sense because the lags won't add a lot of information to a stationary series. This model is not very accurate, like we saw in the first neighborhood, but it's very easy to implement and it's very fast. It's very fast, and it probably work very better with big data sets. And then we tried with a Facebook library called Prophet. With this model, we did first very simple forecasting with just the time series, like Arima, and then we added the features one at a time. As the criterion to add the features, we added the most correlated ones with the rental price in this neighborhood. So it's going to be different for every neighborhood because every neighborhood has more correlated features with rental price, has different features correlated with the rental price. And then we tried with the Prophet and the Neural Prophet, that is a developing library, also from Facebook. We checked which was the forecast comparing the root mean square error. This is the prediction for Pedralbes. Just time series prediction. We didn't add any external feature yet, and this is the root mean square error. As you see, is quite good. The moment we add regressors, it gets worse. The error is worse, but the first 2 quarters are good at prediction. The most correlated features that we added are one of them is related with Airbnb, the yearly availability I talked before, and the number of foreigners that the number of households that have more than 2 foreigners living on them. We also tried with Neural Prophet without regressors and with regressors. In this case, Neural Prophet worked worse, but I think we think this because we have very few data, and for neural networks, more data will be needed. In the Varigotic, this neighborhood in the center, we see that the price go up and then go down after the pandemic. And the time series prediction didn't get that fall in the curve. But the moment we add the 2 regressors, it did get the fall. So it's a bit overfitting, but it did get the fall. The features that we use is more correlated with the price in this neighborhood is the number of households with more than 2 Spanish living on them, and the yearly availability again. With Neural Prophet, we have exactly the same pattern. The just time series model can't get the fall, By the time we add the regressors, it gets the default after the COVID. And with Sagrada Familia, it follows a similar pattern. This is the prediction with profit, just time series, and we add the regressors. The prediction gets better, more for the first 2 quarters. And in this case, the 2 regressors we added, the most correlated, were related to Airbnb, the number of Airbnb listings in Sagrada Familia, and the availability. Neural profit works the same. First, it doesn't get the fall, and the moment we add regressors, it gets the fall. Another interesting thing about profit is that, as is additive model, like Vivian told us, you can get the additive components. Here we see the additive components for La Sagrada Familia, the trend, and the yearly seasonality. And with other regressors, we see how the regressors influence it in the final model. So the conclusions for profit is the extra regressors in general improve the model, so, more for the tourist neighborhoods. Some of the extra regressors are Airbnb related, others are related to the nationality of households. And the neural profit sometimes improves a bit, sometimes not. And I think that is, we think that this is because we need more granular data.
So to wrap it up, we wanted to be extra careful as we combine different data sources into one data set. And we could have missed other features that could impact the final model as well. But with the data set we have, we came to the conclusions the extra features helped our model to predict more accurately, and all neighborhoods' pricing behaviors are different as when we add regressors. And the top regressors for each neighborhoods were different. And all neighborhoods more or less affected by Airbnb features, and central neighborhoods tends to be more affected by Airbnb features. So we could say that there is an impact of Airbnb on Barcelona's rental price, and we were able to predict the rent price for the next 2 quarters.
So what we want to do next, we should gather more granular data for rental price, probably from Idealista or some real estate portal. We would like to add more features that could affect the rent, like how many vacant rental properties are, or if there are vulture funds, or some measures of gentrification of the neighborhoods. Okay, this was all. Do you have any questions?
Well, congratulations.
Thank you.
I really think you did an amazing job here. And I will leave my questions to the end because I want to leave room for, because I've made you many questions throughout the process. So mine will be the last ones. But before I give the room for everyone else, I'll just like to also give a bit of context, right? So Vivian and Antonia, they never worked with this before. So they didn't know the data. So it was the entire journey since the beginning, getting to know the problem, identifying which data was relevant, which was not. Another really interesting challenge they had here was that when we're talking about data points, is that the data, and you want to build a time series model, the data did not come with the same level of granularity. It's not like they had daily data and they could just then pick, I want to do monthly, because data did not come on the same level. So there were many, many challenges here. And this was a very intensive project. And I'm really happy about what you've accomplished. So now I do expect to get more questions. I'll be quiet now.
I don't know, maybe I can start. Congratulations. I mean, it was really like impressive what you did here. And the results as well. I mean, it was really useful, especially living in Barcelona, to see everything that you that you did here. I wanted to ask you. So basically, it really caught my eye, this thing that you found that Pedralbes was a stationary time series, and I think, Antonia, I think you know a bit of Barcelona, so maybe you could tell me, how do you interpret that? How do you explain that? Do you have a theory for that?
My theory is that Pedralbes, it hasn't changed a lot in many years. I mean, it's the neighborhood for the wealthy people. So the type of people that lives there doesn't change. The number of houses doesn't change there. They live in houses with gardens and things like that. I think that's it. The other neighborhoods are more changing. I mean, houses are built in some neighborhoods. In other neighborhoods, lives a lot of foreign people that goes and went. So I think that's the thing.
Absolutely. I think, and maybe they are somehow more shielded from other types of problems like unemployment that could affect perhaps other neighborhoods in difficult times. Maybe in the very wealthy neighborhoods, this is not so noticeable. So in a way, they are protected from these external changes. This is really interesting. And the other thing is, I mean, you improve a lot also the accuracy of the profit model when you use these two regressors, the Airbnb, was it the Airbnb availability and the nationality, which are both related to tourism actually. And this in a way, I mean, this in a way, it enables you to capture the effects of the pandemic somehow, right? You use it like as a proxy for the pandemic.
Yeah, it ended like this because in fact we used the most correlated features. I mean, we just have correlation from Airbnb and employment. You have limited features, but it ended like this. The most correlated features in this case were those two. So
no, that's excellent. And so my final question: how much time did you spend doing the pre-processing for this?
The data.
Yes, preparing the data. I don't know, cleaning the data.
I don't remember.
Was it a long time, or it was? No, tell me.
Sorry, the hard part was finding the relevant features, because it was like not easy for us to finding the relevant features to put in.
Yeah, and the cleaning of the data, I don't remember. It was a lot.
Yeah.
Yeah, but I don't remember.
No, amazing work, and also, I mean, I have to say the interactive dashboard really caught my eye. The map with the indicators. I mean, you could really see how things change in a very easy way. You could show this to someone in the municipality who doesn't understand anything about data analytics, and they will be like, wow, this is something.
Actually, I'm going to jump here to say something. Vivian,
yes,
do you want to share with Joanna some of the exploration you did to identify which features you wanted to use? Because I remember seeing like very long notebooks where you had these heat maps and so on. Do you want to share so everybody here also gets a notion, because you didn't get there straight away?
Yes.
Do you want to talk a bit about that?
Sure, I can just shortly share, but I think I have the kind of short version of it. We cleaned so many times.
But if you want, you can just talk about it as well.
Yeah, so I mean, we this is the already clean version. So we had more, 2 Spanish, and then we kind of merged into 2 or more Spanish, also education levels, and then we had to clean everything, and then we did also heat map and finding the coefficient rate. And then Antonius, the regressors that we used only the highly relevant ones by the model, right? So that was like really helpful, but it was like a long journey. Just as you can see, like.
Sorry, I have to ask this.
All the data aggregated, all the data in a single data set, but before that we have to make a lot of,
Exactly.
So I just have to ask this final question because I'm in Barcelona. So what is the best place to rent a house here?
The most, we found with the most cheap
yes.
neighborhood. Let me show you. It's let's see, the cheaper is is this one. It's La Marina del Prat Vermell, but it's very underdeveloped. I mean,
I don't even know what that is.
It's near the airports, near the Prat, the river. But it's very underdeveloped. It's there are very few buildings there. Yeah, it's very.
And I imagine there are no Airbnb listings in this neighborhood.
Oh, let me see.
There are a few.
There?
Yeah, it's not completely. Let me see. No, there are no. But the price right now, I don't know which neighborhood is this, but the price right now that in the periphery is the cheaper, or you can come to Ruby where I live.
No, also more congratulations.
It's not so cheap, but
well done.
Thank you.
Who wants to ask more questions? Should be so young. What do you want to ask your colleagues?
As usual, you guys, presented it very well. I really want to know the entire process that went into segregating the features you guys wanted and did not want. But I think we can do that in the next class when we have a lot of time. Yeah, so since we discussed the project initially, I know how scattered the data was, and kudos to you guys. This is amazing.
Thank you.
Thank you.
All right, so maybe I can do a couple of questions, but if anybody has, some questions that you would like to ask, think about it, and then you can come after me as well. So one of the things that I was thinking about is when you, Antonia, I think it was you were showing the slide 56, which is root mean square error. So one of the metrics you girls used for your models, can you go back in there? Yeah. Great. So just so everybody's aware, so the root mean square error was a choice that you made, right? So can you share here why? And then also, can you also share how do you make your interpretation out of this error? Like when you see 122, is that bad? Is that not bad? Depending, because it's based on your target variable. So how do you make your interpretation when you look at this metric?
Okay, you choose the root mean square error because well, it's the mean squared error. So the square, what it does mean is that if you have an error, a big error, the square is going to increment it. So we wanted to show in the error the bigger errors. We want them to appear in the value. And we make the root of this because we wanted to have something to compare to the real price. I mean, this is comparable to this scale. If we have a square, we cannot compare to this scale.
Model to models, like, because we are implementing the profit to your profit, and it's like having the mean square errors, like it gives it like kind of scales that we can compare right away.
Of course, different. Of course, we only have 4 points. So the mean square, any square error, any error, the absolute square, the mean is absolute error or the mean square error is going to be very biased if we have just one point that goes crazy. So that's why we show also the graphs, because sometimes we can see that some of the points were not so off. Even the root mean square error is worse. But as you can see here, the two first quarters are not so off from the real data.
Yeah. So of course I'm asking you this so you also share with everyone. So the thing is, when we are developing models, the choice of the metric is an important point, right? And and this was part of the journey as well. Can you also, one of you, share something we do not see here, but you had many neighborhoods. And one of the choices that you did as well was, well, I have to aggregate at some level, because if you had predicted the renting price for the whole city of Barcelona, it would not work well, because as we've seen from your analysis, the neighborhoods have different behaviors, right? Now, there were certain neighborhoods that your trend did not pick up. Do you want to share what you think it happened there and how it looked like and so on?
Let me see. I have it here. Yeah. I had a lot of plots, so let me find.
So while you're finding, so think about this.
This is for example, for XGBoost. This was the graph that Vivian shows, that we can the XGBoost didn't pick the upper levels because of the problems with the model. Yeah, because it's a tree-based model.
I think some neighborhoods also had problems because they had certain really small data set, like a 2 or a few, and then those we couldn't really work on it.
Yeah. And what happens here is that, imagine that you were doing this, you were working with the city mall, for example. And this is when we as data people, right, we go and say, hey, for these neighborhoods, I do not have enough data, but look at these other neighborhoods where we actually can provide reliable information. So that's also one of the key points that both of you found out in this project. My model works for certain neighbors, others not, because the data has missing values, or the quality is not good at all, because even when it wasn't missing, it wasn't reliable as well. So another thing that I wanted to talk, and it's more of a conversation. So the technique that you girls did for the XGBoost, it's a technique. So if you think about it, we have a time series problem. What are we doing? We are transforming that time series problem by using the lags, right? So what I want to also kind of raise, like Antonia mentioned, that when she used the average, the lag, it improved a lot. So what was actually happening before was that by using only the shift, it was not enough. Now, if you think about the time series, what is the takeaway here? Well, I am converting into features by using the lags, but how do I do that? It's a decision when you're making the model. Well, I want to aggregate the last 2 months as a mean, a max, an average, and so on. That's a decision when you are building the data set for your model. So Antonia mentioned, but I just want to flag it because it's not obvious, it's not there. It's part of the journey as well. So yeah, is there any more questions? I don't want to be the only one, talking a lot. Okay.
I can ask a question. Sorry, I had to join late because I was working before. But one of the questions that I had about this housing is, it's nice to think about the rent also, but it's also I think what we call external validity, like all the stuff that you have gone through. Can we try to do it with housing price as well? So rent and price is potentially exchangeable. So can we use the same models with the housing price? And if we do that with the housing price, potentially you can look into like investment analysis. I think it could be good. So if you guys have any idea about like potential problems if you change the Y variable. that could be interesting, that if you don't have any idea, obviously that's fine, but it's something to think about, because obviously you spend a lot of time doing this. So if you can use the same model with some other y variable, that could also be a good application for it. So I was just wondering whether you had any ideas.
Next slide, in the slides there will, because we kind of put the data source when you go and get back to the slides.
Oh, yeah, sorry.
In the next steps, I think, doesn't it kind of answer?
Okay. Yeah, but you were you were talking about the sales, the rental price, not the rental prices. You were talking about the selling prices, right?
Yeah.
Yeah. So we didn't
Assuming that you have
about that,
because you might not have it, but.
But I think, right, I don't know, I don't remember. We explored a lot of data in OpenVCN, and I think that they were data about the selling, but I don't remember.
I think the problem is like we have the ideas, like there must be a way to kind of validate your question, but it doesn't mean that there is a data available, because we wanted to have the data set between 2015 to 2020, and we already checked many data sources and there were not many available sources. So yeah.
Yeah, of course. If you have it, I was thinking that maybe it could be fun for you guys to not have to go through this much time, but just use the same model.
Yeah, definitely.
And do the same.
Yeah.
And actually, I agree in your comment, because intuitively, we do know that they should be highly related, right? So the renting price coming up and also the selling price of the houses. So very likely, if all of a sudden you girls had that data, you could actually try, let me use the same pipeline for that target and see how good I am. So yeah, I really think that's very, very, very good proxy. I just have one final question before we go for the next project. So now that you did all of this, where do you see that your model output can be used to drive decisions? So what type of decisions do you think that this model can help? It can be more than one, but yeah.
Before you're making an investment, I don't know. I'm not sure.
Could be, right?
I don't know.
Vivian, what do you think?
Sorry again?
What do you think it could help for an investment? So how would you pitch your model to have people wanting to pay for your model because you can help them make investments? How do you make that pitch?
That's a tough question. I think
so you're predicting, keep that in mind, you're predicting something for the future. How do you pitch it?
So maybe we can do like also risk analysis, like, you know, your model might, your rent price might be falling down, so you don't want to invest in that area, or you want to invest in a different area, or if you're foreigners, if you want, because I think when there are more foreigners, there's more chance the areas to be gentrified, like by time. So if you want to be more like make sure that your rent price is going to be up, then you can also invest in the gentrified area, like where many foreigners live. Yeah, that's my idea for now. Anything to add, Antonia?
No, I'm glad that Pedralbes is a very good place to invest if you have the money.
Yes. And so that's about investments. So would you say that your model can also help for, let's say, city planning, for example?
Well, I think so. I think that there are no ghettos in Barcelona. Well, there are ghettos, but I don't think we can call it ghettos, but there are a very distant separation of the population. So maybe just call out to the city council to try to alleviate this, not to change it, but to just make it better. Yeah.
All right. Thank you. All right. So again, I think it's great, and I do see a lot of applications for your model, really. So, all right. So let's see the other project, which is something completely different that your other two colleagues did.
Okay.
It was really good to see you guys. I have to jump to the other class, but good job.
Thank you. Bye-bye.
Bye.
So hello everyone. So thank you for joining for this call. So we are Sojung and Shubi, and coincidentally today is April Fool's Day, and then what we are presenting today is a fake news detection using natural language processing. So before going further to understand what is fake news, then I wanted to ask one question, like, did you know that like Trump's grandfather was a pimp and a tax evader, and his father a member of the KKK? Like, no, right? But like from like here, like people like what? And then like people will share things, this article, and did you know, like it started like this. That's how the fake news started. So yeah, like you can see, this is a completely a lie. But if you scroll down, like here, like 3.4 million shares on the Facebook, even though it was fake news, and people like to believe it, I guess. So like this one, fake news is designed to spread the confusion and obscure the truth with lies and hoaxes and the conspiracies. So fake news is on the like legitimate looking websites, or usually social media pages, and stories are designed to be like very sensational, like this one, or very controversial, more likely to be shared. So, and the worst thing is that this fake news can be amplified by bots while you are sleeping. So still the fake news are creating, and then they create some comments under the social media pages, and look like people are actually talking about it. So because of the technology, it gets so sophisticated and very accessible. So news can be quickly published by anyone else, and it's getting harder to believe what we see or what we hear is true or false. So that's where our project starts. So not to be deceived by these fake news anymore, and then by using what we learned from CodeOp. So what we use for our data set, because it's a little bit challenging or also time consuming just to collect all these news, and which is real news or fake news. So for that reason, we've used two data sets. The first one is called Liar dataset, and then this is already collected by the website. It's called polyfact.com, and then the editors are already proved that like it's a truthfulness, which is false or true. And the other one is the Onion dataset, but I will explain further about this dataset later when we talk about the project. So I will show the dataset how it looks like. And this data set, as it contains around 14 columns, and then it's split into three three files, which is train and test and the valid data. And so you can see label and statement, subject, blah, blah. But for the sake of simplicity, actually, we only chose for going for the statement column and the label column, which is this statement shows the actual news statement itself. And this label is from the editors. They categorize it as false or mostly true, or yeah, you can see pants on fire, which is really, really false, I believe. So it's gonna be like this. And then Shivi will take care of how we classify the news, which is a fake or true. Yeah.
Yeah. So.
Okay. I need to.
That's okay.
Sure. Yeah.
So since we're using two different data sets, we are first going to explore the first data set completely, and then we're going to go to the second one. So the first data set, that is the liar data set, this was the graph that Sojang left at. And this is what we like to call formal news. The reason for that is because this is what comes in our newspapers. This is what comes in magazines. This is what comes in the radio. So there's some sort of regulation to it. Coming to the procedure that we followed. So the first step that we did was stemming. Now, what stemming essentially means is getting to the root word. So in this example, if there are words like consult, consultant, consulting, they mean the same thing. But if you take all these words and do an analysis on them, A, your model is going to take a lot of time and resources. And B, the results are not going to be that accurate in case the model takes similar words in different contexts. After we're done with stemming, we create some n-grams. Now, what these essentially mean are group of words. So if n is equal to 1, it's called a unigram. So for example, in this particular example, this is a sentence. Similarly, there are bigrams, trigrams, and so on. Once we did this, we wanted to create vectors. To put it simply, vectors are mathematical representation of words. So if you have a huge map of words and you somehow want to relate them to each other by the form of some score, you will convert them into vectors. So the thing that we used to convert words to vectors is something known as word2vec.
Man, this is so boring. No one cares, man. No one cares. Just stop. Okay, just stop. It's so boring.
It's a tie.
Shubi, I just want to say,
Hello, everyone.
Filipa Peleja leaked the code to your Zoom class. Everyone knows it. Wait, who was it? Who did it?
Is this one of those things?
Okay, I think we removed the spammers. I don't know if there's still anyone left. No, I think it's okay.
Okay.
Sorry, you can continue.
Yeah. So word2vec has two architectures that we follow. There's a continuous bag of words model and there's a skipgram model. A continuous bag of words is when you give input as a series of words and it'll relate it to one particular word. So in this example, pineapples are something and yellow. So most probably—
I still don't get it. What are vectors again?
I'm sorry.
I still don't get it. What are vectors again?
I think those are steps.
Everyone, let's mute everyone. Questions are for the end. Okay. If there's anybody making noise on the time being,
Oh,
we'll
sorry,
be put
my
out
bad.
of the call. Okay. All right.
What would have happened in this example per se is that these four words would have had a score that somehow related to the word spiky. And that's how we got an output. In skipgram, it's the other way around. So we have one word as an input and we find all the neighboring words around it. It's done in a similar manner using a score. In our model, we are using the continuous bag of words approach. Okay, I'll get to this in a while. Coming to Tfidf, this is another measure just to judge how relatable. Is there something that you have to say, Joe? Okay. Tfidf is a measure by which we try to analyze how related a word to a certain category. So just to give you a very small example, say if we were talking about Greta Thunberg, who's very, very passionate about the environment, then we want to know what words are most likely to be said by her and are true or false. This is the formula that is used. It's okay if you don't understand the exact formula right now, but just understand it as a measure to understand how relatable a word is to a particular topic, a speaker, or any such thing. The next step was Pos tagging. We are very fortunate to have libraries who do this for us. This is a process where automatically words are classified into whatever segment of English language do they fall in. So verbs, articles, etc. The reason this is important is because you may feel that articles are irrelevant. A and the, they come everywhere. You may want
Miss, you're looking so cute today.
So you may want to remove them entirely from your analysis and from your data set. I come to the classification now. So there were 6 categories, as Sojang mentioned earlier. We've used the random forest classification algorithm. So it's interesting how this works. It takes data in bunches. So imagine if my hand is the entire map, it'll take segments randomly. These segments may overlap, they may not overlap. What it does after that is it takes some features randomly and then it plots trees. By sheer probability, most of the trees give us the correct output. So what we do is that we find the average of all the predictions and then we have our final output. So once we did it, our accuracy came out to be 25%. While it does not seem like a huge number, in this case, it is a good accuracy, and I'll tell you the relevance. Imagine what the model had to do. It had 6 different segments in which it had to plot simply on the basis of words, and it has done a decent job at it. These are a couple more stats. I'm sure Pelaja is going to ask me this question later, so I'll address it right away. Why did I choose accuracy to tell you guys about it? The simple reason being that for a person who knows data analytics or who doesn't, accuracy is a very normal term. We use it every day. So it's very easy for us to understand in that context. There's another very cool thing that we did, and I must tell you guys about it. So when we are training models, it's a very intensive process, not only for us humans, but also for our machines. So at no point would you want to retrain your model just to get outputs. So there's a process called pickling, in which what we do is that we take our processed data and we convert it into a stream of bytes. We then store it as a file, which can later be reviewed, and we can simply take that and see our results from it. We pickled our data because we didn't want to retrain our model continuously. And then we use that as it is. So our model was saved in a file called model.sav, and we further use that. I would like any of you to give me a piece of news that you may have heard or anything that you just make up, and we'll try to see what the output here is.
Try vitamin D is good for COVID.
Vitamin D is good for?
COVID-19.
Okay.
Miss, can you let my friend join the meeting?
Okay, so clearly that's false. If so, we tried it with a couple of other news articles, and most of those were classified accurately. But let's get a little practical for once. If you are a user and you want to know the piece of news that you're reading, how relevant is it? Do you really want to know the 6 categories that it is in? Because I don't. I, as a user, just want to know whether it's true or false. And so we did a binary classification to make things slightly easier for you. I'll give it over to Sojang to explain the introductory bit, and then we'll go further with the methodology.
Yeah. So like Shubi said, because it was a little bit tricky to see, like if we have a 6 categories, so we actually categorize as a true or false. But for this half true one, it's a little bit obscure for us, and then it could be very confusing for the model. So we take this out and then we put it inside it as a true or false. And as you can see, we have more of false statements. And I wanted to show that like who are the speakers, who are the top 5 speakers at the fake news. And then our favorite person, Donald Trump, is the, saying the most fake news. And then surprisingly, Barack Obama was there. But let's compare with the real news, which is the Barack Obama. Yeah, it's good. Hillary Clinton, and you cannot find Donald Trump here. And like, let's see the what kind of jobs that we like people have in the fake news, which is like president-elect or governor, and then all of them are related to politicians. And for the true news, real news, yeah, also related to politicians, but presidents, yeah, should be, because it has to be in the real news. And then US senator, and on a it was this data set was a focus on the US. So they have this category for state. So apparently like from Texas has the most fake news. Actually, I wanted to know why, but couldn't find the reason. But for the real news, it's from the Florida, Texas. And what are the subjects are the mostly talk about in the fake news, which is healthcare, and then afterwards the tax and immigration subject. And then for the real news, it's tax and the education and healthcare. Yeah. And I did a little bit of checking for the number of the characters for the fake news and also real news. As you can see, we have around 4,000, but here for the real news that we have around 3,000. So I kind of assumed that for creating more fake news, that you have to use some superfluous words to attract people's attention. That's why I think they use more number of characters, but it's, oops, kinds of one of my, yeah, I don't know what happened. Someone tried to mess up my thing, so I will stop sharing. I don't know.
Sorry, this is not you?
No, it wasn't
someone
me.
Else.
Someone else tried to.
Okay, so we have someone here.
Yeah. Anyway, so I will pass on to Shubi to explain the model for the binary classification.
So we use the random forest model for a binary classification as well. I won't get into the details because I've already explained that, but the accuracy score that we got in this case was 62, which is cool. We wanted to dive a little into deep learning, and we wanted to test out another model. Now, we wanted to try out RNN, which are recurrent neural networks. But here's a fun fact. Recurrent neural networks are a lot like us humans. they have very short-term memory. And when you're talking about a machine learning model, you really don't want that. What happens is, over time, some features get forgotten and some redundant ones keep coming back to the model. We don't want this. So what you can see on the screen right now is an Lstm cell. How is it different from a normal neuron? Is because we have gates that have, it's a forget gate and an input gate. I'll give you a small example. Before COVID, there was a lot of buzz about environmental change. People were talking about how the earth is going to end in a couple of years, how we need to take action, how people all over the world are standing up for climate change. The moment COVID came in, news changed completely. We were now talking about healthcare workers. We were now talking about vaccinations. We were now talking about corruption within the medical system. We were talking about homeless people who wanted these facilities. But I'll stop sharing. Regardless, but do you want to forget about that environmental impact? No, we don't. The earth is still getting worse. And that's the reason why we need these Lstm models and why they are a lot better than recurrent neural networks. Can I share my screen again or should I wait?
Yes, you can share your screen. So what we're going to do, unfortunately, we're going to have to remove everyone that we don't know. It's the best. And next time we need to be more careful. Probably the link got shared in Twitter or something like that, and it got exposed. So, so for those who are not bots, we're very sorry. So I'm going to ask Joanna to remove everybody we don't know. So we can continue your presentation.
You can remove Philippa. I put you as host. Yeah.
Okay. So continue, Shubi, and I'm just going to remove who we don't know. Okay.
Yeah. So when we work with our Lstm model, we got a slightly lower accuracy. That was 0.542. And even though we were happy, we wanted to go with the model that gave us a better result. And so we did our final prediction with the random forest model. I'll use the same example that we used in the last one. Again, it's false, but you see the truth probability score is pretty low. Now I'll tell you the reason behind this. The data that we had taken is pretty old. At that point of time, COVID did not exist. So what would have potentially happened with the model is that it didn't find COVID anywhere. It could not have related it in any case. Yet, it may have picked up words like vitamin, good, curing, and found out that these are usually hoax articles. Let me give you a little context. Have you ever come across a really bizarre beauty treatment that makes no sense to you? That is a form of fake news that gets propagated a lot. Get rid of acne overnight with this mixture of washing powder and acid. But do you really want to do that? No. So that's, again, one of our fundamental ways of working around it. I'll give it over to Sojang again, as now we are moving on to our next data set.
So like I explained, it's called the Onion dataset. So it's on the Reddit actually, and then it's scrapping. We scrap the data from the API because I will explain it what the Onion datasets about is. So the Onion is on the fake news website, and then they have their own sister's website is called a Clickhole, and then they uploaded this articles on this Reddit, and then people followed and then see through these articles. And then there's another one called Not the Onion, which is like you can see all these real news. So we can dip inside of what the data looks like. So this is not the onion part. Like you can see these something limited size, and the onion, yeah, like this. We've got data and we clean it. So we have these 30 things. So clean it up the data. I'll keep it a little bit fast. So we scrap the data between the 2016 to the 2021 for March for the onion data, and not the onion one is just 2020 December to the 2021 March. And we see who are the authors of the onion, which is the fake news, is someone else at the IDs. And for the not the onion was this two. And what is the most reference domains for the onion? Like aside, you can see the onion and the Clickhole, which is the sister company of the onion websites. And the reason is that because of this data set is only allows for the onion.com data or their sister data sets, which is Clickhole. So that's why you can see that the onions.com data is prominent. And therefore the most reference for the real news, the Guardian and the CNN and Independent. And then I will pass on to Shubi for explaining more about the modal side.
Yeah. Before we started segregating into true and false, Sojang mentioned how the onion always gives you false news and not the onion gives you true news. So just to make it easier for us, we converted it into 1 and 0, where 1's for true and 0's for false. What we wanted to do was find, and this was something that Pelaja asked us to do, to first have a baseline model and then build on top of it and try to keep getting better as you do so. So for our base code, we just took the count. So we counted the number of true and false values. That they came out to be 54 and 45. Since we've learned so much in CodeOp, we wanted to make sure that our model performs better than 54%. To do that, before I move ahead, I want to discuss the 4 combinations that we took. So we used count vectorizer and Tfidf. Tfidf, I mentioned earlier. I quickly scroll to that. Tfidf, as I mentioned earlier, had this formula, and it was how relevant was it. Count vectorize is relatively simple. It just counts. So a normal example, the red dog, you see the counts have incremented. And further on, as the counts keep getting incremented, the sum would be the addition. So essentially, cat would be 2, eats would be 3, and so on. My first model was a count vectorizer and a logistic regression. I took this because it's the simplest things that you can possibly do. In this, we got a score of 0.82, and we moved ahead. We did another model. We kept logistic regression as the same thing, but now we changed into a Tfidf. We got a slightly worse result in this case. And then we went on, we kept using other permutations and combinations. Our third one was a count vectorizer and a multinomial NB model. That's a Navy Bayes model. So this is the formula that we use to find Navy Bayes related predictions. For someone who does not know this relation, Navy Bayes, essentially, it finds the probability of one thing happening on the basis of something that has already happened. The fourth model was what was left of the combinations. And our best model was a count vectorizer and a multinomial Levy-based model. Here's the confusion matrix, which we are rather proud of because Pelija said it's a very good confusion matrix and she was very happy. Now another thing that we had to do, and this was what Sojang was very passionate about, and so was Pelija, was to find certain words that we could use to determine if a news was more true or less true. Initially, Sojang told you guys a fact that false news took more characters. Now we'll understand why that happens. So these are some words, and we found out how their coefficients impact the news. The ones on top are the ones that have a higher probability of making the news false. And the ones that have a negative coefficient are the ones that will ensure that the news is more true. I want you to look at words like beautiful and incredible. Now let's go back to my example of fake beauty articles. Get incredible skin in 3 days. Get beautiful hair in 4 hours. On the other hand, if you look at other words that have a negative coefficient, notice how they don't exaggerate. They're to the point, they're related to the topic. So there's Bitcoin, vaccine, and so on. Also, another thing that I would like to point out is that the previous data set was a rather old one. The data that we scraped right now was current, so we could have more insights into the news that's going on right now, and hence you see COVID here. Also, I forgot to mention, but some words have been blacked out since they were a little sensitive to our audience. Once we did that, these were our final conclusions. We found out our best model. And I think one of the most important things that we found out and what insights we took back was that incredible was one word that made a news 10 times more likely to be classified as false. And Australia, surprisingly, was the word that made a news 15 times more true. So with that, that's the end of this data set, and I'll give it back to Sojang, who will explain you what we plan to do in the future.
Yes. So just share the screen. So like, well, we found from the data sets that there are some very limitations for cleaning up. Like I showed some of the EDA, like who are the top speakers and blah blah blah, but it was still the data was very dirty, and I just took it as it looks like. But I think it would have been better if we could classify it like and put it in the model with a cleaner version of the data sets. And the other limitation was still this data sets, like Shibi said, is from I think 2018, so it's a little bit outdated. And for Reddit one, still is how to say, like it's I think I put it, yeah, the amount of the news a little bit small. So I think it would be nice if we could gather more bigger data sets that we could feed on the model. So, and that was our limitation. But if we have more time, I think that would be good work. We could gather more data sets. And the other one is we would like to make this a WhatsApp kind of fake news detection. So whenever you read the news, you just put it in like, hey, what is the news header says, or kind of sentence, and then it will show you the accuracy of this news article, which is a true or false. So that's what we wanted to do. And yeah, I will wrap up here, and hopefully our fake detection helps you to decide which one is fake or not. So don't get deceived by this beautiful or incredible kind of articles anymore. So thanks.
Thank you. And I'd just like to say sorry for what happened, for all the spammers that we got into our session. Well, we'll take this as a learning as well.
Exactly.
And I again, I'm going to do the same. I'm going to leave up to your colleagues and, Joanna also, and Antti to ask questions. So Antti is a student that I also invited. She has her project on NLP as well. So I said, well, do you want to hear about another colleagues who are also working here? I just want to say one thing. When Shuvi and Soyun came to me to talk about fake news, I was scared because I was worried because it's a big challenge, right? So when you look at that first 25% of accuracy, you do realize how challenging it is. How do I know if something is half true, half false, right? So that's a level of granularity that it's very, very challenging. But I do see that we had amazing results, and you can see really interesting insights that they make sense, but they were automatically driven from models. So that's also a very important point. Like nobody went there manually to hand that out for us, right? Okay, but I'll leave my questions to the end. Go for it.
Okay, I feel a little bit under pressure to ask questions, but I do have a genuine question. One thing that I raised to Philippa, so my model was to predict purchase or not purchase. So also two classes like yours, based on consumer reviews of product. And one thing that I asked Philippa is, well, I ended up using word factors. I didn't even try the bigrams or anything. Did you make a conscious decision? Did you experiment, and what was your observation to decide on what you were using eventually?
I'll take that question. To be honest, we were taught NLP by Pelija, and she taught us in a very systematic manner. So these were certain things that she ingrained us to definitely look into. So to be honest, they were not decisions that we chose. We were just taught to think that way, and so we did those things. But yes, in hindsight, when I look at them, following a certain pattern or a certain way of doing things does impact your model. What Sojang and I did was that before we did anything, we just vectorized it and then we applied our models. And the results are so bad, I don't even want to show them to you. So then we kept adding one step, and then we kept retraining our models. So that's just how we figured it out. It's not us, it's mostly Pelija.
Okay, so it was just like a trial and error kind of thing.
Yeah.
I think I can also add something to your question, Antti, before you go, Vivian. So the thing with n-grams is that the larger your data set, the more likely the n-grams will add value, because n-grams will be visible in your data less often than the unigrams. So one thing that maybe we've seen on this work, right? The n-grams did not add that much value, right? It was not obvious, right? But it will most likely be visible if the data set was larger, because it will have a higher relevance. Okay, so that's one of the points also to consider. Okay. Also, then another point regarding n-grams, they are more meaningful as well, right? So if they are more visible, they're more, you can actually capture that importance. It means that you found a very important feature in that, which is an n-gram. Okay, I think of it.
Sorry, yeah, maybe mine is very basic question. Sorry. First of all, I really like your model and like how it's formed, and it's really amazing, the outcome. I was like wondering what's the reason why you use the onion part, because I was not fully getting that part.
So the thing was that if we were in the 80s or the 90s, then your primary source of news would be newspapers or the radio, or maybe television if you were rich. But in today's time, you get news from Instagram, from Reddit, from 9gag, from WhatsApp. So, you know, the sources of news are very unreliable. And, you know, we had trollers today. There are a lot of people who spread fake news that way just because we have the social media. So, Onion and Not the Onion, they are both pages on Reddit. And everyone can type anything they want over there. So Sojank and I, we felt that we wanted something more relevant and something that really harms teenagers. So at the expense of quoting a slightly more uncomfortable example, you know, there was a time when a lot of teenagers were committing suicide because of some video games. And that was a very unsettling time for the world. The only reason those children, teenagers, were getting access to that was because it was all over the social media and there were news articles claiming a lot of things that should not have been said. And that was our primary purpose for using Reddit and the Onion.
Yeah, in the beginning, I texted Philippa privately because it really made me chuckle because I didn't know there was this data set, the Onion versus not the Onion. I was a fan of the Onions. Like I read it regularly when it was still, you know, I read the print version. So this is like we're talking, you know, like the notice. And so it's a satire publication, but you know, some people like me, we just enjoyed like because it's a parody, like almost. It was like always fun to read, but it's great that, you know, like now they have this data set and you guys actually did an amazing job to use that kind of data set for fake news detection. So yeah, amazing.
Thank you.
I just want to say congratulations. I mean, amazing results. I mean, I can see there is a lot of work behind this to prepare this. And I was really impressed also with the final results that you got to these correlations with the keywords. I have to say I was a bit surprised to find out that Bitcoin and COVID are negatively correlated with fake news, because I thought that there's so much like, you know, stuff around, hype about, you know, Bitcoin and COVID, but apparently it's not the case. It's more serious. People who talk about Bitcoin are serious somehow. That was really impressive. I wanted to ask you, so what is the size of the data set? Maybe you said it and I missed it because you keep saying it's small.
Sorry. Yeah. So for a liar data set, it's around 20K. So okay. Yeah. And then the onion sets was around that much as well, or smaller, right? Yeah.
So it probably would be really interesting to extend this study, as you said in the roadmap, with the different data sources like WhatsApp or Twitter or I don't know, of other, to see if the conclusions still hold, if it's the same type of semantics in the different channels. That would be really, if you are willing to continue working on this, which I hope you do, because it's a really good piece of work.
Yeah, thanks.
Congratulations.
Yeah. Thank you. Any other questions?
I think Philippa.
I have, of course.
Yes.
All right.
A simpler question, probably. Can I go first?
Go.
So have you guys gone through like any manual annotation process? Like, I don't know if it was necessary or not.
I'll take that question. So we tried, but it's just that it's news. It's all over the place. There are a lot of things. So we weren't very confident doing it. So we started it. We did show it to Pelajor. She really encouraged us to go ahead with it. But that's something that we'll do later.
Yeah. Tried it and then it doesn't look good, so we stopped. So yeah.
It got complicated for us. So.
Oh, by the way, just like one silly thing, I was just curious, how did you black out the sensitive words?
It's a trick.
So so the thing was that they were two bad words, and every time I showed them to Paraj, I would be like, "Are you sure I can keep them?" And she was like, "It's just us, we are family. But when you go out to an office, make sure you remove them." So I was like, "Yeah, sure." But then she gave me the idea to not run my Jupyter notebook. So I took a screenshot, I blacked out the words, and I inserted it as an image. And I did not run the notebook for anyone. I just showed it.
Okay, maybe I didn't read your code closely. I didn't realize it
Yeah.
was an image.
Yeah, no, I can show it you right away. So here, I use this function. So I just inserted the image. And since it's just us right now, this is the actual output. And yeah, then we did that.
Okay, I thought there was some magic happening, but thank you for sharing that.
Yeah. Also, since we're here, there was another thing that I wanted to tell everyone about. So I found a way. So you know how ebooks have indexes, and then you click on that index and you go to that page. So Sojang and I discovered a way in which you could do that to Jupyter notebooks. So for example, this is our index. Now, say you want to see the most active authors. Then all you have to do is click, and then you go to that part of the Jupyter notebook. And the syntax is very easy. So you just take square brackets and you write what you want the link to say. And then you just write the first two words or the first line of that statement over here like this. So yeah, this was something very cool.
Thanks for sharing. It's marked on.
Yeah.
Is there more questions? No? Okay. So I'm going to, put you a bit of a challenge. So you showed us that you were able, through the coefficients, you identified words, and it could have been n-grams, but now we are talking about words that are more related to being fake news or non-fake news. But as Joanna pointed out very well, we might have, fake news that have COVID in it, Bitcoin in it, right? So if I don't understand anything about your model, how it works, how would you justify when you have an article that your model says that it's fake news, but it has the COVID word in there, and you are at the same time telling me that COVID is a word that is not from fake news? Can you explain to your colleagues why you are able still to identify that it's not fake news, even though it has the word COVID in it? Maybe I can help you. You explained the vectors, right? You explained that. Can you explain why then, if you take that?
Yeah, okay. So I've understood this thrice from Tereja, and now I can successfully explain it to you guys. But word vectors was something that I did not understand at all. And so I kept pestering her to explain it to me. And she told me to look at it in such a way. So imagine a playground where there are a lot of children. And you know how children have best friends and they have enemies. So they'll always be playing with their best friends, and they will never be playing with their enemies. So they'll be in two corners of the playground. And that's how I understood word vectors. So stuff that's related to each other is clubbed together, and stuff that's not is not. In your addressing your question, if an article does say it's fake news and you see the word COVID in it, it's probably because the other words in that article outweigh it. That can be one reason that I think. Sojang, is there anything else that you would like to add?
Actually, like I didn't think that the vector side, but the thing is about the data sets, I would say, because the onion and the not the onion part, because apparently not the onion, like you can see the main the most reference domain was from the Guardians or BBC, but the other ones just people are just writing as a comments. So that's why not many people were talking about COVID or vaccine compared to the real news. So that's my assumption. So that's how our model built. That's yeah.
Yeah, you're right. That's I didn't consider that, but the source will also play a very important factor in determining whether it's true or false.
But the intuition you're saying is exactly that, right? Because in the end of the day, the model will take everything into account, regardless if it's the count vectorizer or is the Tfidf, or even because you showed that you also work with the Lstm. So that's, I mean, just to also share, because there was a bit of noise at that moment, but what the girls was showing is that there's a model that takes into account while being built, because it has the different parameters that is learning, because it's a neural network model, what happens before and after. All right, so it's long short-term memory. So there was a lot of effort in here also on leveraging that model for this data set. Now, another point, we said 20,000. 20,000 sounds like it's a lot, but then you downscale because you want the positive and the negative news, right? And then you downscale because you have some comments that have very little words on it. So it's a very, very challenging problem. That's why, you know, you need volume. Now, another question. So let's say that you were explaining and you said, I mean, and this is for both of you, I'm saying you, but it's for both of you. You mentioned that Tfidf did not actually boost your model, if I got it right? So it did not have a high improvement on the results, right? Right. So, but intuitively, would you say that it should? And if it did, why not? Then why didn't you see it?
What I can think of the top of my head is, so just giving you an analogy, I learned linear regression. I was like, yeah, it's super easy. And then I learned more complex models. And I was surprised when the first time a more complex model underperformed linear. I thought that couldn't happen. Linear is the others had to be better. So that's somewhat what happens. Count vectorizer is just counting it. And Tfidf has an entire formula that's to it. Coming to Joe's example of COVID, she was surprised how it was in the negative list because there's a lot of fake news around it. So probably Tfidf got confused at certain stages because COVID may have come a lot of times in positive and negative news. And maybe that's why it, and there were a lot of similar words. That's my assumption.
Okay, Sang-Yun, do you want to add something? I also only have an assumption. I don't know either.
Yeah, me too. But like you said, I expected that the Tfidf has better solution, but apparently it's not. But yeah, this is how it got.
So my assumption is, I think your results were not worse, but just like more or less the same because it was marginal, the difference, right? So my assumption is the following. So count vectorizer gives you the total count, as Tfidf is going to actually normalize it. So first point will take how many times I observe it, but also normalizes based on the total amount of words. And then looks at the other class to see, oh, if you also happen the other class, I'm going to penalize it and push it down. So I think the data set that you girls use, the documents are not very big. So there's not like a huge variance. So one of the things that sometimes you do I have a huge variance? Like in the same data set, I have very long documents, then very short documents and so on. So if you don't have a large variance, it means that you're not as concerned on normalizing, because if I see 2 times and in another document 2 times as well, it doesn't really matter to normalize it because both of the documents have more or less the same dimension. Okay. And the same thing would apply if you think about the other component, because it's putting down, if I observe on the other side, maybe it didn't actually weight that much. So that's my assumption. So it's not because Tfidf is not a better metric, it's because you had a data set that did not have a high variance and at the same time did not have enough volume to be able to put down some words that you didn't care about, and at the same time, it did not push up some words because the documents were more or less the same size. Okay, because those are the two strong points of Tfidf. If you don't see there, basically what you can say is that, well, I'm good enough with the count vectorizer because it's more than good an approach for my model, which was your case. Okay, so I wanted also to raise this because, you know, sometimes we read some articles and they say, hey, this is the way to go. Well, it's another example. It depends on my data. So my data here, what it tells me is that I don't need to take a more complex approach because it does not add value. Okay. And I wanted to, you talked about a lot of stuff, but let's say again that I am here listening to your work, I'm learning about it. And if I would ask you in terms of challenge, what would be the biggest challenge that you said that you encountered while developing this? What was harder for you to come to the final solution throughout these weeks?
Yeah, can go ahead.
No, please. There was just so many that it's difficult.
Because I shared theses with the girls, by the way. We were looking at articles, we were looking at theses, right? So
yeah. So I'll start with the most fundamental problem, which was we liked the liar data set because everyone loved it on the internet. People had written papers about it, they'd written theses about it. But the problem was it was very old. So that was one problem. And then we had to apply our mind and actually scrape out data, which we tried in the past too with another thing, and then it had not happened. So that was the first challenge. I think after that, oh, So Chang, your challenge of adding names. I didn't know about that.
About the cleaning the data? Yeah. So, because even though on my EDA, I was only sharing that like who are the top 5 speakers, it looks clear. But if you look inside, it's such a long list of the speakers, but it happens to the other features. But I tried to group it because I think, like I said, it was from the human who is the editor from this website, and then create this and like this is half true or true, something like this. So they put it manually about the jobs or states, something like this. So it could be grouped it as a politicians or something, but for the like blog posting, it was all false news, but still it write it in a different way, so I couldn't group it well. So it would be, it was a little bit shame that I couldn't use that feature. And then it was hard for me to, figure out how to use it for my model. It took a while, that part.
Actually, I had that question because I wanted you to share that with the class as well. Because if you think about it, if you have a data set, why did they pick only the statements and not the who? Because in that data set, we had who and their job. And while we were brainstorming together, we even, there's certain assumptions we take, like my job might have a huge relevance, right? Because if I am a minister, maybe I'm less likely to, promote fake news, right? Because I have a certain responsibility and I might lose my job. So Sonyung actually went through that journey. And truth to be told, I do think that if you had more time, you could leverage value from those, but they are so noisy and so hard to work with. We had to postpone it for future work. Okay.
Yeah, and we tried removing it also, but then half our database was gone. So we didn't.
Sorry, I just have to interrupt you because I have to leave. Congratulations to all of you. Great. Well done.
Thank you
so much.
Bye-bye.
I'm not going to massacre you much more. Let me see. I had one thing that I wanted also to share with you. Okay, it's my final question, but it's one that I love, so I have to ask. So you took 2 data sets And you mentioned that one of the reasons is because one was older, a much older data set, and you wanted to see, well, what if I take a similar approach to my problem in terms of how I build my pipeline, right? Does it work, right? And you saw that actually you could, kind of take the methodology into a new data set, and you've proven that it works as well, because you had very good results for both. You also shown that, well, I can distinguish when it's clearly fake or non-fake, but in between it's another story, which, by the way, is the same thing that happens with sentiment analysis. When you try to be more granular, it becomes really subtle because it's language. So the models are able to capture better the extremes, and in between it's harder. So just for the future, one of the tricks sometimes is if you had, let's say, news articles that are bigger, it is better to chunk by paragraphs, and you evaluate on the paragraph level, because you might have paragraphs that are true, and in the midst you have false paragraphs. And if you look at the news article as a whole, you are misled. So then again, it depends on your data, right? So my question is, if I wanted to buy your product as a product, like your model, and I would say, okay, I really like it, but my domain is, I don't know, tourism, okay? How hard it would be for you to adapt your model to my problem? And I'm saying tourism, like there's fake news, they're talking bad about my city, about the prices of my houses, and there's a lot of crime here, this sort of things, right? So how much effort do you foresee that you would tell me as your client, like, I would need to make these changes, but or what you would ask from me? What do you need from me to be able to adapt your pipeline to my problem?
So, Vivian asked us the question if we had done a lot of feature engineering, other tagging, which we had not. So, to be honest, this model is a very basic model. You can apply it on any data set. But if I were to ask you for information, I would first of all want a complete data set with reviews, with the location, with price factors, with crime rate in the region, and other things. Because according to me, your problem cannot just be solved by NLP on the feedback comments. That's very difficult.
Yeah, I was about to say that thing, but also think, like you mentioned, it has to be a little bit certain if it's a good or bad, like in between. If we have those kind of data sets, I think it's a little bit tricky too. Yeah, that's why
I would challenge you.
I
would say you need to be more proud of what you did. It's not really like that. So you've shown, I mean, even though we didn't have time here, you identified characteristics that show that fake news that certain news are more likely to be fake. So news that are true tend to have more numerical features, percentages, links to the source. So there are other things that we saw together, even though you didn't have time to go through it. There are actually a lot of characteristics that you can leverage from an NLP perspective to be able to accommodate that. Of course, you would need data from tourism. And for the data you are asking now to me, like, oh, I need the criminal numbers and those, of course, that's your ground truth. So then to see if you're making it right? So you want to compare, but your model, you can take your model as a starting point, okay? Because it is a starting point. And if you think about what Facebook, and I'm going to say Facebook, what Facebook is doing, right? So Facebook has models to detect if bullying, if text that is bullying, and also fake news is happening. They're not going there manually. So they have what you can call anchors. And what are those anchors? It's part of the work you already did. You might call it simple, but it's a starting point. And that starting point is fundamental for you to understand what are the key points in a given piece of text that pushes me more towards, you know, the edge of fake or the edge of truth. And you have that, of course, and you need to build on top of it. Okay.
Sorry, so these anchors that you talk about, could you give an example?
So for instance, when you were saying incredible, amazing, the coefficients, those can be seen as anchors, right? So I'm calling it anchors in the sense that are, because many times we refer to anchors in text for pulling towards something. And you see what's happening around that anchor, like what are the words around those anchors. It's just an idea, but the fact is that you are able to identify them. You already have a pipeline that leads you there, right? So you're not at, let's say, at 0 kilometers. You already did a couple of miles. So that's what I mean. And it is something that we can absolutely do through NLP. Now, of course, we could say that would be nice to get some annotation. So what does the real life systems do? They ask randomly to, you know, can you report it? Right? So some people voluntarily go there and report because they have that option, right? So this is how you get the ground truth. And that's how you make your NLP model real time, because you are able to constantly be learning, because language is changing all the time. So it's not only about you have very good domain today, no, because we are very creative as how we write. So that would be, let's say, the next step of your pipeline, if you wanted to put it that way.
Yeah. Oh, yeah.
Right.
Okay, go ahead.
All right. Well, anyways, I really think this was, both of you, I mean, your projects, girls, were really, really, really amazing. It's not easy because you landed here and you learn everything from scratch, and most of the time you were on your own. I was kind of, let's say, only your mentor. I didn't even do hands-on with you girls. So that's, I mean, kudos, right? Like Joanna was saying. One thing that I think you girls should, you know, boost more, it's your confidence. Okay. So you did something, be proud of it. If I challenge you, you need to, you know, it doesn't matter. I can solve your problem. And this is for both groups. I can do it. And you just need to think in that moment, what do I need extra? Because I have something. And you need to train that. So it's to build your self-confidence on what you did. Even if it doesn't resolve everything, it's not simple. There's no doubt on that point. Okay. Right. So your projects tomorrow, and then I'll give you my written feedback on the report. All right. Is there anything you want to ask me before we go?
Oh, do we have to share our Jupyter notebooks with you?
No, it's just a oh yeah, you have it there as you want. If your report will be through the Jupyter notebooks, yeah. But put it as a PDF, maybe it's easier, because I'm going to make the comments on the document next to it. Okay.
Okay.
Yeah.
And Auntie, thank you for joining. I hope you liked it.
Yeah, I do. And I just like want to echo what Philippa said. Like you did an amazing job, because like I know how hard it is, because like it was also quite painful for me, like to, and I think like you actually did further than I did. So congrats.
Well, we would love to do a project which you're already doing. So yeah, we would love to help you out with it as well.
Thanks.
All right. Well, thank you, everyone.
Thank you.
Thank you.
Thank you. Bye. Bye.
Bye.
Bye.